Alright, here's number 14 from section 7.2 as requested. Looking at this problem, trying to prove that angle X is congruent to angle Z, given that AC is parallel to XY, given that AB is parallel to CY, and given that angle ZAC is congruent to angle XAB. Oops, that's the wrong angle. Angle ZAC is congruent to angle XAB. I'm trying to prove that angle Z is congruent to angle X. Looking at this one initially, I want to try to prove, if I could prove this triangle congruent to this triangle, then I know that those corresponding parts, X and Z, would be congruent. However, looking at this problem, it doesn't seem like there's any way to do that, okay? You don't know anything about any of the sides of those two triangles, so you're not going to be able to prove those triangles congruent. But luckily, all I'm trying to do in this problem is prove angle X is congruent to angle Z, and we just learned a theorem that says if I got two angles congruent in one triangle to two angles in another, then I know the third angles are congruent. So if I can somehow prove that these two angles are congruent, angle ZCA and angle ABX, then I know by the no choice theorem that would make angle X and angle Z the same. So that's going to be my goal for this particular case. So let's see how we would be able to do that. Okay, so just at a quick glance, I see right now something that's true about this quadrilateral right here. All right. What do you think is going to be true about that? Well, since nobody can answer me, you can answer me at home. That's going to be a parallelogram. Okay. And I'm going to say that right here, ACYB is a parallelogram. Reason being, the two pairs of opposite sides parallel, then it's a parallelogram. Very simple. Well, why do I want to say that? The reason is because a parallelogram's got a ton of properties, okay? One of those properties, the one that actually is going to help me with this particular proof, is that the opposite angles are congruent. So my step 3 is I'm going to say angle ABY is congruent to angle ACY. Okay, the two that I just marked are congruent because if it's a parallelogram, then opposite angle is congruent. Okay, that does something pretty cool. That allows me to say these angles are congruent. Angle ABX and angle ACZ are congruent because they're sub to congruent angles. So I'm going to say that in step 4 is angle ABX is congruent to angle ACZ for the reason that we learned like day 3 was if two angles are sub congruent angles, then those two angles are congruent. So that's angle ABX and angle ACZ. Well, great. What I have now is in these two triangles, let me highlight them. This triangle and this triangle, I have two angles that each congruent to two in the other. So that means by no choice theorem, angle X is congruent to angle Z. And I can just write no choice theorem. If two angles in one triangle are congruent to two angles in another, then the third angles are congruent. There is no other choice for those angles. That is a 5-step proof. Okay, a little bit tricky because initially I wanted to prove the triangle is congruent, and I saw that kind of led nowhere, and you have to then prove that you have two angles in one triangle congruent to two in the other. So hopefully that helps you with number 14, section 7.2.